Okay, so I'm going to do some tests of how much power things draw. I'm going to first do the standard unmodified 59 that I've got, and right now at idle it's drawing 156 milliamps, and I'm feeding it 4.3 volts directly to the terminals. Why 4.3? Well, because that's the voltage with the battery is really topped off, and that's also the voltage that that I feed it with a 6-volt supply. One that being is 4.3. So, and this is within the spec of the chip. It is the max on the spec, but it is the max, and so I use that because it makes the display better, and I think it makes everything just sort of work a little better. Maybe not, but but I use that anyway. So anyway, so this falls right in line with the specifications that are published on this. Now what I'm going to do is I'm going to load in the first I'm just going to load this in, and we're going to see the current go up as I load it, because the card reader is what really draws all the juice. So, so that's 350 milliamps is what it drew when it ran the card. So, you know, quite a bit more than normal. Now what I'm going to do, it's funny, what really draws almost the most is the LED. So this is with just a 0 on the, or just a 1 on the display. I'm going to run the standard diagnostic program now, and then it jumps up to 176. So this is in use. So this is active, and then, but when the display goes all 8s, that's when you get 230 milliamps. So this all agrees real correctly with the published specs for the standard on the calculator. Also, this gear's all calibrated, so this is all really correct. I'm getting my voltage from a precision voltage regulator, a module. So anyway, so there's all that. Now what I'm going to do is I'm going to change over and check the overclocked modded calculator. Okay, so now I've got the overclocked modded calculator. So at idle was 0, about 158 milliamps, so about the same as the other one. We're going to load this. Now this is about 330 when we loaded the card before, so we're going to do that again. So let's load the card. That was about 330, so that was about the same. And now we'll run the diagnostic. That's 187, 188, 183. So altogether in 240 when it's finished. So that's really very similar. There's really not much difference in power draw. So what that'll mean is that the battery will last basically the same amount of time on the overclocked version, and that we're not really drawing any more power, which is what I also saw checking thermally on the various chips. None of them really were getting hotter. So this clocking, this 600 kilohertz resonator producing a 300 kilohertz clock seems to be normal for these parts. I've detected no errors running continuous diagnostics for almost 48 hours now, so looks good to me. Okay, I'm going to do a much more direct comparison of the amount of power that's being drawn, the amount of current being drawn with the standard and the overclocked device. So this is the standard device, and this one's drawing about 160 milliamps at 4 volts. And I'm doing that right on the batteries. I'm feeding the battery terminals directly to 4 volts from a regulated supply. Now what I'm going to do is I'm going to load in the memory test out of the service manual, which causes the calculator. This program will run the calculator really intensely at full active mode continuously. So I'm going to go ahead and do that. And now we're at 186, 185, 184, somewhere in there milliamps. Now what I'm going to do is I'm going to set null. What that's going to do is that's going to show us the difference between. So now it's just subtracting that 180 and just showing us the difference. You can see it going plus and minus as it draws a little less and a little more juice as it's running. So now what we're going to do is we're going to put this calculator away, and we're going to move on to the modded calculator. And we're going to do the same thing. So at idle, it's running, interestingly, a little less current at idle, which is kind of fun. Oh no, I'm sorry. This is without running the. This is without running the program. So let me go ahead and get the program running. Okay, and now what we're doing is we're running a loop. So this calculator draws approximately 20 milliamps more than the the stock calculator. So the overclocking is pulling about 20 milliamps more than the standard one, and that's at 4 volts. So they're similar, and the difference isn't too bad between the two. That's a good thing. That also agrees with kind of thermal measurements. I'm not really measuring any temperature differences with all the chips. I've checked all the chips; they're not really measuring any difference. So this looks good for the overclock.